All right, so on number 8, here on this problem, we're dealing with this idea or this postulate that all right triangles are similar. Doesn't matter how big or small it is, what the angles are inside, all right triangles are similar. Meaning, all the side lengths of the right triangle are proportional. So all the smaller legs, all the bigger legs, and all the hypotenuses are all similar, or they will be proportional because they're a right triangle. So you'll notice how I broke down all 3 triangles that I see in this picture. And you'll notice how I rotated and broke apart each one to see which triangles they were. I even labeled all the sides A, B, and C. I made all the A's of all 3 triangles the smaller leg, and I made all the B's the longer leg, and C is always the hypotenuse. So looking at number 8, it wants to know XW. So when I do XW, it's right here in the blue triangle. That's what B is. So I'm going to put B next to XW up here. And then we don't know what it's proportional to. That's what we're going to figure out. And then we use the second proportion there, ZW, which is in our bottom purple triangle, which is right here. It's A in our blue triangle. And then YW is on our bottom purple triangle, which is also A. So A is proportional to A. So we need to find the B that's proportional to XW. But we have to use the same 2 triangles. So ZW in the purple triangle is what is proportional to this particular triangle. So it makes a real big difference if you can break apart each triangle, and obviously it's easy to see that I'm comparing the 2 legs of the blue triangle and the purple triangle. So I didn't even have to use the red one or the original triangle. So it makes it really simple if you can identify which sides are belong to each other. And I usually do that by picking the side lengths that are, the shorter legs are always A, the longer legs are always B, and the hypotenuse is always C. And I just do that to make it easier for me. You can label whatever you want, but I just label it that way to make it simpler on me. So, in this picture here, we see that this ramp, and we want to find the altitude of the original big right triangle, which are all the measurements there. And so we want to find X, where that is. Okay? So again, let's label all of our triangles as we see them here. So we have our original triangle. So our original triangle, I know it's pretty bad drawing, but I'm trying to go quick here. So we have 26.6 as our hypotenuse. We have 12.8, and we have 23. So just for arbitrary labels, I'm going to say 12.8 is A. I'm going to say 23 is B, and 26.6 is C. All right, and then let's go ahead and just take a look at the smaller triangle there. Okay, so the smaller triangle on the upper right side, let's go ahead and draw that in. So, and I'm going to flip it around like this. So it's a little taller, but I want the right angles to be in the same place. All right, so we know that 12.8 is the hypotenuse of this triangle. So in this triangle, it's 12.8, and we don't know what the other side lengths are. All right, and so we know that 12.8 is C, the shorter leg is A, and the longer leg is B. So in my triangle, X is actually B. So this is what we want to find. We want to find out what B is in this triangle. So what I'm going to do is set up a proportion where I have the two hypotenuses I know. So let's do 26.6, the hypotenuse of the big, over 12.8, the hypotenuse of the small, and that will be equal to the B of the big triangle over B of the small triangle, which I don't know. So when I find that out, I should be able to find out the altitude of this triangle. So I'm going to do some calculations here, and the way we solve this proportion, we cross multiply. Okay, so I'm going to do 23 times 12.8, and then I divide that by 26.6, and I get an answer of 11.06, or if we're rounding the nearest tenth, it would be 11.1. So that's how I find the missing height. I look at the information, I try to draw the triangles, and then I want to find out which part of the triangles are similar, and which parts of the triangles I already know I can set up a proportion for. So that's how we do that problem. Let's do one more together before we wrap it up here. So again, we have these men working on a scaffold here. All right, we know our big triangle. Let's go ahead and draw that out for us here. This is our big triangle. Here's our right angle. We know this will be 10, this is 8.8, and this is 13.2. All right, and then let's pick the bigger triangle this time, just because I'm feeling wild and crazy. Let's draw a bigger triangle for the next one here. And the bigger triangle has actually a bigger base this time, and not as tall of a height. And there's my right angle. 10 is the hypotenuse in this triangle, and x is A, and this will be B here. And looking at my triangle, this is A, this is B, and this is C. So, here's C, and this is A. All right, so A is the side length we need to find out. We need to set up a proportion that will get us A in one of our proportions. But typically, what we're given are the two hypotenuses of this triangle. So let's set the two hypotenuses on a proportion. So 13.2 over 10 is equal to so we want to include A because we want to figure out what x is. So 8.8 is the A of the big, and x is the A of the small. So that's what we need to figure out. We can do that by cross products here. And then we'll just plug it in and solve. So 10 times 8.8 is 88. And then 88 divided by 13.2 gives us 6.666, or x is equal to 6.7. So that would be A, or the missing height of that right triangle. So what we do is we set up the proportions. You have to find the matching sides. Again, I like to label it A, B, C, A being the smaller leg, B is the bigger leg, and C is the hypotenuse. And then you just try to isolate, or again, the only variable you want is the missing height or the missing length that you need. And then you do cross products and proportions to solve for the missing variable.